Hi everyone, so now we're going to be talking about compound inequalities, and compound inequalities are essentially just two inequalities meshed together. And there's two different kinds of compound inequalities. There's the first kind I like to call and inequalities, and then the second is or inequalities. So with and inequalities, you get an equation that looks something like with an x in the middle and then two numbers on the outside. Or there could be an equation in the middle, there could be an equation on the left and the right side, but as long as you have two inequalities in the same equation. And when we graph and inequalities, you find the two answers, you find your two solutions, you plot the 2 points on your number line, and then you connect the two dots. With an or inequality, you have two separate equations, and those equations are kind of connected with the word or. So what you'll do is you'll solve both of the inequalities and then plot your two solutions, and instead of drawing a line in between the 2 points, you draw arrows on the outsides of them, pointing away from each other. So let's go through some examples on how to actually solve these. The first example is an or inequality. Let me scoot this over. So the first example is m plus 7 is less than 3, or 2 plus m is greater than 12. So this is an or inequality because of this word or right in the middle. What we're going to do is actually just solve these separately. And so let's start with the left one. When we solve this for m, you want to get m by itself, which means that we need to move the 7. To move the 7, we're going to subtract 7 from each side. So I get m is less than negative 4. Now I'm going to do the same thing on this right equation, inequality. I want to get m by itself, which means I need to move the 2. To move the 2, I'm going to subtract 2 from each side. And I get m is greater than 10, because 12 minus 2 is 10. So my two answers are m is less than negative 4, and then m is greater than 10. And because I had the word or in between my original question, I'm going to put the word or in between my answer. So these are my two solutions. And then when we graph it, what we're going to do, I know it's not the same, it's not the exact number, but we're going to find negative 4 on the number line, and we're going to find 10 on the number line. And we're going to put points on those things. And if you remember, open dots means that it's just less than or greater than, and then closed dots means that it's less than or equal to or greater than equal to. Because these are just less thans or greater thans, we're going to put open dots on the negative 4 and 10. Then because it's an or, we draw arrows that are kind of pointing away from the center. Now let's just double check that that makes sense. The first thing says m is less than negative 4. So less than would mean smaller than, and that arrow is pointing to smaller numbers than negative 4, so that makes sense. And then the second one is m is greater than 10. We're pointing the arrow to numbers bigger than 10, so that also makes sense. Okay, now let's go through another example, and this example is going to be an and example. So this says negative 14 is less than 4 plus 3n is less than or equal to 25. So we know this is an and inequality because there's no words there, and you have two inequality signs in the same equation. Now potentially we could solve this as is, but I'm going to actually show you how to separate them, because we're going to come through some more complicated equations, and it's going to be easiest to separate them first. So when we separate them, what we're going to do is actually just take the first two chunks for the first equation. So negative 14 is less than 4 plus 3n. And so the very left chunk and then the middle chunk. And then for the second equation, we're going to take the middle chunk, 4 plus 3n, and set it less than 25, and then the last chunk. So you have the middle chunk in both equations, but the end chunks are on either equation. So now, because we know this is an and inequality, I'm going to just write this word and in between them. And now we solve them separately. So on this one, we're going to subtract 4 from each side. We get negative 18, and then 3n going to divide by 3 to get rid of that 3 by the n, and then negative 6. Okay, and then, so we know this negative 6 is less than n, and I'm going to leave it like that instead of putting the n on the left side, and there's a reason I'll show you at the end. So now, on this side, we're going to do the same thing. We're going to subtract 4 from each side first, and then we get 3n is less than or equal to 21. Then we're going to divide by 3 on both sides, and we get n is less than or equal to 7. So we get n less than or equal to 7. So now what we can do, we can write the word and in between these two solutions, but we can actually mesh these together so that it's a number is less than n is less than or equal to a number. The n's just kind of mesh together into one n. So I can write it as negative 6 is less than n, which is the same as that inequality, and then is less than or equal to 7. So like this part is this, and this part is this, and it just kind of smashed together that n. So when we graph it, we're going to find negative 6 and then 7, and we're going to plot our points. So it says negative 6 is just less than n, so it's an open dot right here. And then at 7, it's a closed dot because it's less than or equal to. And then because it's an and equation, we can just connect these two dots. But let's just make sure that makes sense. So it says that negative 6 has to be less than n, which means that n is greater than negative 6. And so it has to be bigger than negative 6, which makes sense in this graph. But n also has to be less than 7 on that line. That line is less than 7. So everything makes sense. That's your graph. Okay, let's go through the next example. And the next example is another OR equation. So this one says 4x plus 2 is less than or equal, or sorry, not equal to. Let's see. Let's erase that. Okay, so less than negative 6, or 3x plus 10 is greater than negative 8. So once again, we're going to just solve these individually. So I'm going to subtract 2 from each side. I get 4x is less than negative 8. Now I get to divide each side by negative 8, or sorry, divide each side by 4. We get x is less than negative 2. And then on this one, we're going to solve for x again. So we're going to subtract 10 from each side. We get 3x is greater than negative 18. Then divide by 3 on each side to get the x by itself. We get x is greater than negative 6. So now I have x is less than negative 2, and x is greater than negative 6. So when I graph those, I have negative 6 on this side, negative 2 on this side. Now, they're both less than, not, or greater than, not less than or equal to, or greater than or equal to, which means that they're open dots. And then normally, because it's an OR inequality, I should put the word OR right there, we would draw arrows that kind of face away from each other. But let's just see if that makes sense. So this x is less than negative 2, the first thing. When x is less than negative 2, it wants to be below 2, which means that the arrow should actually be facing this way, right? And then it says, or x has to be greater than negative 6. When it's greater than negative 6, the arrow should be facing this way, right? Now, what that means, like, normally, like we said, the arrows actually face away from each other, but in this case, they're facing towards each other. So when we have arrows facing towards each other and it's an OR, what that tells me is that my answer is actually all real solutions, or all real numbers. And the reason why my answer is all real numbers in this case is because if something is less than negative 2 or greater than negative 6, that covers every number. Because think about this. This arrow can keep on going this way, right? Past the 6. And then this arrow from the 6 can keep on going this way past the negative. I'm sorry. The arrow from the negative 2 can go past the negative 6, and the arrow from the negative 6 can go past the negative 2. So it just keeps on going, which means that it covers every number on the number line, which means your answer is all solutions. So sometimes when we do this, you have to graph them first to make sure it makes sense. And if it doesn't make sense, then your answer would be no solutions. Okay, let's go through one more example. This last example is an and example. And you've got these two inequality signs. So what we're going to do is we're going to treat it like what we treated the other and inequality, and we're going to separate the two equations. So the first equation is the left side in the middle. So we have 5 plus 6r is less than or equal to 7r plus 8. And then the middle and then the last. So 7r plus 8 less than or equal to 6r plus 9. Now I'm going to solve those. So what we're going to do is get the r on one side. And in the last video I told you to get the variables always on the left side. I'm going to put my foot in my mouth a little bit here. I'm going to get the r onto the right side in this case. The reason why I put the r on the right side, particularly in this specific question, is because I want it to end up looking like some number and then an r and then some number. So this r wants to be in the middle. In order to make it in the middle, I have to put it on the left side of this left equation, or on the right side of the left equation. So what I'm going to do is subtract 6r from each side, and I would get 5 is less than or equal to 1r plus 8. Now I'm going to subtract 8 from each side, and I get negative 3 is less than or equal to 1r, which is also just r. Okay, and I'm going to just erase these so we have some more space. Alright, now we're going to solve this equation on the right. This time I want to get the r on the left side, so I'm going to subtract 6r from each side. So I'd get 1r plus 8 is less than or equal to 9. Then I'm going to subtract 8 from each side, and then remember 1r is the same thing as just r, so we can say r is less than or equal to 1. So now I have negative 3 is less than or equal to r, and r is less than or equal to 1. I can smash those two r's together, so it'd be negative 3 is less than or equal to r is less than or equal to 1. That's my solution. So now when I graph it, I have negative 3, then 1. They're both less than or equal to signs, so we're going to put closed dots right here. Then because it's an and, we can connect those two dots. Let's just double check that that makes sense. So is negative 3 less than r less than 1? That tells me that I need r to be bigger than 3, so that means that line has to be on the right of 3, or negative 3. And then r has to be less than 1, which means that it has to be on the left of 1. Okay, that makes sense. It works. That's my graph. Okay, and that is how we solve compound inequalities. So you want to solve the equations, graph them, but also make sure that the graph makes sense, because sometimes, like in this third example, you're going to end up with something that maybe doesn't quite make sense or doesn't fit the norms. And when it doesn't fit the norms, your answer could be all real solutions if it makes sense, or no solutions if it doesn't.